So my students want to feel more like it's class, so I made a class, and this is the front half of the class. And we're going to factor 3x squared minus x minus 14 using the calculator. Here's the big screen for you. And Margot, can you name any x coordinate that you can read off the screen? And Margot says, hey, it looks like the curve goes right through x equals -2. It gets that tick mark right on the money. But Kayla, what do you think about this positive intercept over here? And Kayla says, well, it's between 2 and 3, so it's a fraction. But knowing that we have a -2 over here for an intercept means we have a factor of what, Rye? And Rye says, I think we have a factor of x plus 2, because if -2 makes the whole thing 0, then x plus 2 has to be a factor. Well, let's see if we can factor it that way. I've got 3x minus 7 times x plus 2. So there's the x equals -2. And I have to get that 3. So I'm going to multiply by a 3x. And I have to get that 14. So I got to have a 7. I need a negative x to happen. So -7 plus 6x, -7x plus 6x should do the job. Well, let's type that in and hit enter and tell it to graph for us. Let's see if we get the same curve. And it matches up exactly. Yay! So we factored it correctly. So we factored it, and we got the 3x minus 7 times the x plus 2. Let's do the next one. Yulska's going to start us off. What do you think, Yulska? And Yulska says, you know, if it was up to me, I'd graph it on my calculator because maybe I can see what the intercepts are right away. So I've punched it in and graphed it, and let's see what the graph looks like. Oh, that curve, can you see it? It's pretty thin, but it shoots right through 1, 2, 3, 4. So that means it has a factor of x minus 4. So let's look at that equation again. If I have an x minus 4, then I need a 2x. And I need a 5. And all I have to do is make that -3x happen. So Stephanie, what do you think? And Stephanie says, well, you know, it might just be 2x plus 5 times x minus 4, because this x minus 4 will give us a 0 when x is 4. And then I get that small negative number on the other intercept. If you go back to the graph, you'll see that I've got a negative intercept and a positive intercept, and we factored it correctly. Brenna, how do we know that we factored it correctly? And Brenna says, oh, because it overwrote the other equation. The two equations have to be the same because all the points are the same. And Zoe says, can we do another one? And I say, oh, we'll do a few more, but I have to let the other students in the class talk. 2 more polynomials to factor. And the 25 minus 9x squared is going to have something different. It's still going to be shaped like a parabola, but can Trinity tell us what's different? Trinity says, well, there's a minus on the x squared term, which means the parabola, instead of opening upward, is going to open downward. So let's see if she's right. I've punched in the graph, and it's appearing on the screen there. Trinity was right. It's facing downward. Now, anybody have suggestions about how to factor this thing? And Taylor says, well, the two intercepts are fractional, which means you're going to have a number in front of each x and then the other numbers. You're not going to get, you know, just 1x minus 7 or something, because you got to have like 2x or 3x in front. And I say, is there anything more? And Abdal says, well, look, you got symmetry. It's perfectly, the parabola is perfectly symmetric. These two x-intercepts are the same number. One is a plus and one is a minus. Well, let's see what that means about the factoring. That means that we have factors that look like this, and this is famous because it's difference of squares. You have 5 minus 3x and 5 plus 3x. 25 becomes a pair of 5s. 9x squared becomes a 3x and a 3x. You just have to have a plus or minus. Well, let's see if that factoring is right. We know it's right. We know difference of squares, or you're supposed to be learning it. So let's graph these two together and see what we get. And the line is turning green. Perfect overlap. We've got it. Good job, you guys. Now we factor the next one. Taylor, can you start us off? And Taylor says, well, let's see. That one's got a 4x squared. So we could either have a 4x and a 1x or a 2x and a 2x. Let's see what the graph looks like. So luckily, Carly brought her graphing calculator, and she is graphing the thing right now. Oh, that's a really interesting situation here. Can everybody see this? That the parabola just touches the x-axis. That's a very special situation. That means there's only one number that makes the curve have y equals 0. So that means what? And Zach says that means that the same factor has to happen twice. Elliot, can you name what that factor is? And Elliot says, well, you have to have a 2x and a 3 because you can't use 9 and 1 and you can't use 4 and 1. The two factors have to match. Well, let's see if Elliot's right. I've got the original and then 2x plus 3 squared. So you only have one factor to the second power because we only have one way for this function to be 0, and that's at x equals -3/2, which fits the picture. Let's see that picture. And the curve overwrites. Perfect factoring. Good job, you guys. Let's get those factors written down again. If everybody would just mind their P's and Q's and not get too out of hand. And now everybody starts saying, oh, this is the worst class ever. Why are we in this class? I never talked so much before in my life. Oh my God. Will this thing never end? And I say, well, it will end in just a minute. Here's the final factored forms that we had on the calculator screen, but here's the answers all together. And I'd like to thank all of you for being so cooperative today. Look how much fun class is when everybody participates. Thank you very much.